To the second day of SFSCon. Today we are here at the Software Architect track. We will have 9 speakers of all around the world. We will have a short break, and we will also have the possibility to have questions at the end. We'll have questions here in person, and afterwards we'll try also to ask the questions we get online. For our first talk, we have Christian Patterson. He's senior consultant for Huawei, and he's working on open source community building in Europe. Today he will tell us about quick apps. Christian Patterson, welcome.
Thank you, and welcome everyone on this bright and early on Saturday morning. Thank you for having me here, and thank you for your time, of course. So today we're going to speak about quick apps and open source, and leveraging the open source dynamic to explore the mini app or the quick app dynamic for mobile applications. Okay, so we know that society is moving at a rapid pace towards the digitalization of all of our lives. We can search online for random facts. We can video call family members. We can post stories. We can check out food facts. We can shop and go. We can pay for our taxes online. We can book travel online. Everything is moving online, including our house devices, for example, fridges and lights and other things. So we're moving towards a world in which most of what we do is going or being represented in a digital format. And often these require additional applications that we must download from an app store onto our phone, as an example. Added to this movement, we also know that there are a huge number of mobile phones, and that growth is growing. So at the moment, the number of mobile phones in the world represents about 6.4 million devices, which is obviously huge. That's like 80% of the global population. And if we look at the two graphs on this table, I don't know if it's easy for you to see. The numbers, I guess, aren't so important, but it's the trends. So on the left, we see the smartphones are the bulk of our digital media diet. So we see how that trend is increasing, and which is the lower section of each column. And we also see that mobile traffic, now this is on the right-hand graph, is hugely increasing. So this is really an exponential curve. So really, we see this combination of our lives are moving online, everything is becoming digital, and at the same time, our mobile devices are becoming more and more central to what we do. Now, this creates multiple pressures. So companies, big and small, public services, organizations, increasingly need an app presence in order to reach their intended marketplace, intended audience. Whether you're a museum or a government office or a small local shop or a hotel, having this app on a smartphone is becoming the norm rather than the exception. But the problem is that writing and publishing and updating apps is actually not so realistic for many of these organizations. I know personally of examples, and I'm sure you do as well, of applications that get put online. You download them and then they don't get updated. They become kind of these phantom applications that kind of sit there, never changing year on year. And that's because many organizations don't have the manpower simply to keep up with this. We also know that marketplaces, these online stores where we're getting our apps, are being filled by literally millions of new apps each year. So as a user, it's harder to find an app. And I don't know about you guys, but I go to an app store, I type in a few keywords, and I get presented with literally hundreds of applications for what it is I'm trying to do. And so what I'll do is I'll tend to download these applications. Well, not all of them, of course, but maybe a handful of these applications, and I'll try out the first one or two. I might keep one that I think is great. And what happens with the other applications? Well, I tend to leave them on my device thinking, oh, well, I might find that useful, or I might go to it if the first application isn't useful. But of course, after a few months, it's still there and I haven't got rid of it. So this kind of links into the third point, where our devices are becoming bloated with apps that we no longer use, or we used once for a weekend or for a few hours. Now, I'll come back to that in a second, but let's continue on the second bullet point here. So not only are the app marketplaces being filled with millions of apps, and these apps are brilliant. I mean, there's some great apps out there, but there's just so many, right? It's a deluge. Um, but that also creates a problem for the app developers and app publishers. They just can't get that app seen in many cases. So you see that it's really kind of difficult for the developers to push their app onto, say, the front page of an app store. Often these are selected by the app marketplaces. And so if you're not on that front page, how likely is it your app is going to be seen? So a problem for users, problem for businesses. Now we've talked about the app download problem. Obviously, filling up our devices. So, what happens is people tend to buy a new device, or when it's time to buy a new device, they kind of look at their memory usage for the current one, and maybe they'll up the memory, the storage capacity of their new device, and they'll buy a device with more storage capacity. Or maybe they'll be using their device, and when they go to download something, it's not possible because you have to delete some apps and all this kind of stuff. So it's kind of a problem area, right? And not only is it a problem area from a usage point of view, it's not very eco-friendly. So it's not really working towards sustainability goals, and it's not very adapted to developing countries. Plus, it costs more money for us as users to buy these devices with more and more RAM. Right, so it's a problem, right? And we know it's a problem. It's a problem for developers, it's a problem for businesses. Users are becoming tired with all of this model. It's what we call app fatigue. And this is especially true if it's an ad hoc need. And what do I mean by that is maybe you've gone away for the weekend and you want to download an app to get the map of the town that you've gone to visit, or maybe just get into a parking place in the hotel. Everyone is kind of bored with this kind of thing, right? Okay, so we see this kind of perfect storm starting to be created. You can see the clouds, right, turning. And we know, now let's add on to all of this problem we've just discussed. What about IoT? So we kind of mentioned, we touched on that at the beginning. We touched on this kind of explosion of everything going digital, but we know, well, here's some graphs that show it, right? So soon, your coffee machine will be connected online. You just, tap an app on your phone, or tap your phone to your coffee machine, and boom, it's going to order you some coffee beans, right? So, all of these things are coming online, parking meters, everything around you. So when you combine these elements, there's app developers making apps for absolutely everything because we expect them, to be honest with you. Developers can't get their stuff surfaced. Users are tired of hunting and searching and downloading. You kind of see this problem of water everywhere, but not a drop to drink. Okay, so as a kind of a final kind of, let's say, nail in the coffin, the app market, the app dynamic that we know today was really kind of developed and launched back in 2008. And what we're seeing now is there's a concentration of these marketplaces. We're 13 years on from that, and we're starting to see there's a concentration of marketplaces. You can see back in 2010 here, there were several marketplaces, and now there are only a couple of big ones where everyone is getting their apps. So this duopoly obviously has given rise to certain antitrust questions that are being looked at around the world. And you're noticing that there is this a pushback in terms of developers starting to say, well, how can I have my app more easily distributed? How can I create visibility for my app? So we need a new mechanism. Everyone is kind of coming at this from different angles, but everybody's kind of saying the same thing: is the app dynamic as we know it needs to evolve. It needs to move on. Okay. So we believe that quick apps are part of the solution. Now, there are many different technical ideas that are being developed at the moment, and they're all great, of course. And we believe that the mini app and quick app paradigm is one of the key solutions to this kind of perfect storm scenario that we've just had a look at. Now, what are mini apps or what are quick apps? And I need to accelerate because I've only got 5 minutes left. So mini apps are this growing paradigm for mobile applications that support or are being implemented within the W3C. As you see on the left-hand side of the screen, quick apps are an implementation of mini apps. So mini apps can also include these mini programs done by various companies such as Alibaba and Baidu. Quick apps as an implementation are supported by over 1.2 billion devices worldwide. And they allow an installation-free native experience. So what does this mean? It means you snap a QR code, you scan a QR code, should I say, and the application you're trying to get hold of launches instantly. So you don't have to go through the standard user experience of going to a marketplace, tapping the keywords, searching and all of that. The app just launches. So you can imagine embedding these QR codes everywhere. Imagine putting one by the reception desk of your hotel or at a museum. You know, everyone is using audio tour guides at the museum, and we tend to use these kind of tour guide machines that the museum will give us. It's not always the best experience. So, you know, wouldn't it be better to use our phone? So snap the QR code, start the tour guide, and off you go. So it's a great mechanic, lots of possibilities around kind of viral marketing, which of course is interesting for developers, and campaigns, business campaigns, that kind of thing. Also much easier to develop because they're using a light framework. So I've got some examples here. I'm not going to stay on this slide because I am running out of time. But here you can see that these quick app dynamic actually can work across various use cases, whether it's in-car infotainment or health services or utilities or gaming. In fact, we were recently at another event and we were with two gaming companies who were demoing their games. So, and that was FRVR and Famobi. So shout out to those guys, they're fantastic. So yeah, you can have gaming experience through quick apps. It's a near native app experience, but without the download hassles. As I've mentioned, coding is simplified. You're going through a view model view controller paradigm. It's a Vue.js-like. Use mainly JavaScript and CSS, basically. So it's pretty much accessible to any developer in the world, which is also great as well. So we help to democratize the development of applications and rich applications. So everyone's a winner, users, developers, and businesses. Now, again, unfortunately, I can't stay on this slide too long, but we do see a huge potential for this. Now, why are we talking about open source and why are we pushing now the OW2 Quick App Initiative around this? Okay, so we've mentioned that quick apps as an implementation of the mini app standards are supported by quite a significant number of devices. And what we should now come into is the fact that most of those devices are in Asia, places like China, India, and other countries in Asia, but almost non-existent in Europe. Now, of course, that's a problem because we think this is a fantastic dynamic, and the companies and organizations that are also within the initiative already think this is a fantastic dynamic with lots of potential. So we need to get that out to the European marketplace or the ecosystem, which is why we've launched this Quick App Initiative. Okay, so what is the Quick App Initiative? The Quick App Initiative on the northbound side is working to create awareness and also working to create knowledge around quick apps. That's with businesses, but also with developers. Both sides of that coin need to understand the benefits, the opportunities, and how it works. We're also looking within the Quick App Initiative to collaboratively create tooling. This will create organic growth. And on the hardware side, we need to push out the push out the technical platform that allows devices to natively run Quick Apps. So Quick Apps run on what we call a Quick App Engine, and that needs to be installed by the device manufacturer. So W3C standards. Okay, I've run out of time, but I've only have a slide or two left, so I'm gonna just finish. Okay, so the Quick App Initiative is opened up by design. It's a fully open source initiative. We're open to all. There's no restrictions, which is obvious, really, considering it's open source. The deliverables are open source as well. We're using OSI and CC licenses for maximum reusability and, of course, the collaborative process. The working groups, all of the deliverables are managed by working groups or task forces. The deliverables can be documentation, and as we go forward, more and more, they will be code related. We're using the OW2 infrastructure, and it's a fully open source governance. On the website, where there is a link on the next slide, you will see that we have a charter which is extremely meritocratic. There's no pay to play, everybody is equal, and it's fully transparent in terms of the minutes of meetings and all of these kind of things. Okay, so that's the Quick App Initiative in a nutshell. There's this a problem area around the digitalization of our lives. App developers aren't happy, users aren't happy, businesses aren't happy, something has to change. Quick Apps are part of the solution. Quick Apps are an implementation of W3C standards. The Quick Apps run on many devices, especially in Asia, but in Europe, we need to grow the ecosystem. And the Quick App Initiative will collaboratively work to foster that ecosystem, both on the awareness, knowledge, and technology side, with your help. So here you see the link and, of course, the QR code. My name here, Christian Patterson, and hopefully we'll see you soon. Please come and have a look at the website, read some of the articles, and jump on board with us. We're at the beginning of the journey. And we think it will be an exciting journey where Quick Apps play a significant part of your future smartphone life. So that's my discussion for today. Thank you very much for your time. Sorry for running a couple of minutes over time, but I hope you found this interesting, and see you soon.
Thank you, Christian. Thank you. Nice presentation. Maybe we have some questions online. You can check there. We'll need to switch now because we are already out of time, as you know. But thanks in any case. So after a short break, we're back. Bye. So our next speaker works as a researcher at the Free University of Bolzano, where he focuses to find better ways to develop software Today he will tell us about software analytics. Welcome to the stage, Eduardo Guerra.
Thank you very much. My name is Eduardo Guerra. We are going, let's say, in summary, we are going to talk about better ways to use metrics, mainly for making meaningful decisions. Before I start, I will talk a little bit about me. I'm a researcher in Unibizeta. I come from Brazil. I have 5 courses in Coursera about agile and software design. I lead an open source project called Sphinge Framework, which is not one framework, but a set of frameworks that kind of have the same design philosophy. And we have like more than 10 frameworks that includes like frameworks for gamification and continuous experimentation. I'm a board game designer and I have 2 books published on programming. So let's go. Right, so I put here some sentences that are already here in some development teams. Like, oh, I think the clients would like if we do the interface this other way, so let's change it. Or I think soon we will have more clients, so we should update our infrastructure, or we need another server, something like this. From more technical point of view, right? Oh, I think this might be a problem for performance, so let's spend, I don't know, 2 days working to improve it. Or I think that this part of the code requires urgent refactoring, right? So based on what these developers make this decision, right? If you ask for them, they would say based on experience. But if you ask them what is this experience, probably something like this, right? Like something that they, I don't know, do some magic or something, because sometimes it's hard to be sure. Right? But you can say, okay, no, it's not, no, yes. So for the amount of resources that you are going to spend, for example, in a huge refactoring or on change your infrastructure, I think it's not enough, right? You need to be more sure for how much you are going to invest on this, right? But you can say, okay, but we do have some metrics, right? We have some tools that shows us very colorful charts, especially if it's in green, then our managers really like it, right? But actually, when you look at these tools, most of the development teams are like this, right? They actually don't know what to do with all this information, right? I don't know if some of you knows what this magic number means, 42. You know, right? Okay, so for who don't know, this comes from this famous book from Douglas Adams, right? In which they created a big computer to give an answer to life, the universe, and everything, right? So after millions of years processing, the computer finally give an answer, right? 42, right? So then they figure out that they know the answer, but they didn't know what is the question, right? So for me, when you just use a lot of metric tools, it's like you have a lot of answers, but you don't know what are the questions for these answers. So it's like 42, right? When someone just show, oh, look what cool I measure, right? So, and you ask, what is this for? I don't know yet, but, oh, so then you just say, oh, this is 42, right? This is an answer, very cool answer for a question that we don't know what is it, right? So I see that people are more like, oh, let's find which metrics can help us to solve our problems. Oh, no. I prefer figuring out what we can do with the metrics that we already have, right? So yeah, so let's meet analytics that can maybe save us from this, right? So first, yeah, that's the boring part, the definition part, but I think it's important, right? So analytics is a data-driven approach. So we are basing our decisions in data, right? And the goal is to support decision making. So this is the main goal. It's widely used in marketing, for example, for making better decisions, right? Now, let's talk about software analytics. Is to use these analytics, right, to make decision, to make this data-driven decision in software projects, right? And in this definition, I highlight this part, right? The goal is to obtain insightful and actionable information, right? So it's not just to get numbers, to measure something, right? You want to make decisions, you want to make actions, and then that's the reason why you are going to collect this information, right? So you can use it for many purposes, right? I will not read all of them, but just like, for example, for making a better testing, right? For improving your process, right? Or even to choose what can be the next features for your software, which ones will get more value from the customers, right? And you can get this information also from several sources. I will not also read all of them, but for example, you can get from your code repository, you can get from your source code, you can get from your running software, which can be metrics collected at runtime and both data from the application database that also have good information. So you can get this information wherever they are that can help you, right? So we have some values for applying this. So the first one is that every measurement should be done for a reason. You should not just measure because you are measuring, right? The entire team needs to be aware of the analytics process, right? Every time that you give a constraint, right, and the people don't understand the reason of that, they kind of hack, right? I always give the example like, oh, okay, I think everybody will agree that smaller methods are better than big ones. But start limiting, then people can break the methods in terrible ways, which are much worse than the big ones, right? So everyone needs to be aware of what is the goal and why we are measuring this, where we are trying to achieve, right? We can't just stop the project, right, just to do analytics, so we have to find a way to embed all of this in our development process in a way that we will not like stop everything just for measuring and figuring out what to do with this. And finally, the result should be decision and actions and not just numbers, right? So, oh, I find out this, but what action, what decision you make with that? That's the goal, not just get the numbers. Okay, so when we look at the literature, we find out that most of the teams that successfully use analytics are large teams from large companies that have a whole infrastructure, maybe a teams of PhDs just for taking care of their analytics, right? But how we can make it suitable for small and medium-sized teams? So this was our goal. So based on that, we identified a set of practice. I will not also go through all of them, but just to say that, for example, the first one is what you need to know. So the first thing is to identify what problem you need to figure out, right? What you are trying to solve, right? We have, for example, the small steps for analytics. So we are going to plan these steps, and then we are going to try to embed it in our development process, right? We have these reachable goals. It's not to define some impossible goal that the team will never like, oh, we need 100% of that. Oh, test coverage. We don't have nothing right now in a huge code base. That's something that we're not going to achieve fast, right? So finding reachable goals, embedded improvements in day-by-day tasks. So we have this set of practices for implementing the analytics, right? And then we find another problem, which is when we are doing analytics, the team's goals is in one place, the metrics are in other place, and then we make decisions, and it's hard to connect the things. Oh, you are making decision because you did get this metric and make this analysis, and then you decided that. Sometimes this is not visible for everybody, and even who is doing this have some hard time tracking that. Because of that, we propose a software analytic canvas, right? It's an idea, it's a place that you can put all the information and help you to manage this analytics process, right? So I will give you an example in the field of software architecture. I have much more, right? Come back. Right, so the first you start with the key issue. What are your problems, right? So I will pick up this one. It's fiction, but it's based on true facts, right? So why sometimes reports take too long to be generated by the software? Imagine we are in a team and we have this problem, and we are going to try to use the canvas for it. Right, so the first thing is to figure out some measurements that can help us to better understand this problem. So in this case, for example, imagine that, oh, okay, so just a disclaimer. I'm not saying that are the only metrics, or this is the way of using the canvas, or this is the only way to solve this problem. I'm just showing how the canvas is used, right? A team can figure out other metrics or go in a different direction, that's fine, right? That's just an example of canvas usage. So we have there some measurements like response time, request rates, and the CPU usage on the server. The teams figure out that can help. You can see there is no tools there. So then we are going to figure out how we are going to measure that. So maybe the team decided that they are going to use some logs to capture the start and end of these requests, right? And a tool to monitor the CPU usage in the server. And I don't have that, then I will put there in the tasks, right? So everything that I need, every time that this process stops, that something needs to be done, goes to the tasks, right? And then I do the tasks. I can do in small steps, and then I will figure out some highlights, something that pops up from my data, right? So in this case, I find out that we have a large delay when multiple reports are being requested at the same time, right? And then we continue our analytics process doing the other tasks and also find out that these are the moments in which the CPU on our server are, the CPU usage is extremely high. So based on this findings, we just go deep on the data to find out what we can find. So in these insights are our interpretation of this data. And in this case, we find out that what was happening is that when the report starting taking longer, the user go there and click refresh several times, and then several requests for this heavy functionality are being requested, right? And also I talk to the client and find out that the report does not need to be returned immediately. So I can make decision and establish goals, right? So in this case, my decision is to make these processing reports asynchronous. Again, it's not the only possible decision that I can have, but in this case, I decided to do that. Right? And also I put a goal that I don't want for the CPU usage on my server to go through 9%. So when that happens, right, I want to know and I want to avoid that. Maybe I need to update my infrastructure. And based on that, I also add more to-dos to try to fix this problem. I'm finishing. So the idea of this lean analytic canvas is to help you to reason about, to put everything in the same place in which you can discuss and evolve on the analytics process with your team, right? And we applied that in 2 case studies, one in a software startup, one in a multinational company, right? If I remember right, in the software startup, I think the main problem was the lack of testing. So the analytics process helped them to find the most important places in the code to start testing. And in the multinational company, the issue was about the services performance. So following the analytics process, they find out what were the bottleneck and how they can improve it, right? And then I leave you this message. So try to stop, right, just measuring random things just to get a 42 or trying to guess, right? And I leave here my email. Since we are talking about metrics, I leave a ton of things. And there in Unibizeta, we work with this kind of thing. So if you are interested in collaborating with us, just please send me an email and get in contact, and we are going to be, that's going to be a pleasure to collaborate with you. Thank you very much.
Thank you, Eduardo. Thanks, nice presentation. I also liked your memes, really nice. We'll have again like 3 minutes of pause and we'll see you soon. For our next talk, we have Ivan Proschenko, PhD candidate at the University of Trento. He will show us how technical leverage creates opportunities, but also has some risks. Welcome to the stage, Ivan.
Thank you. And indeed, like the previous speaker was like introduced to us that we need to know why we need a metric to not receive the 42 answer. And actually, I want to present yet another metric. Well, okay, joking. I hope this metric will be useful and will let us get the nice result. And I will be talking today about the technical leverage metric to measure the FOSS dependencies in open source projects. This work was done in cooperation between the University of Trento and the University of Amsterdam. Just a quick introduction about myself. So now I'm a research assistant professor at the University of Trento. I done my PhD there, and before I was at the intern at SAP Security Research, and I worked at the leading security engineer in an oil company. In the free time, I like to do snowboarding, hiking, and also play volleyball. And for the last several years, I regularly present our topics at this conference at the SFSCon, and I'm really glad also to be here today and present in presence. So, about software. And well, about rabbits. So basically, we can think that software can be like a big, slow rabbit that we really control, and we just sit on it. And then if we have any problem, then we just can spot it and maybe fix it immediately. But in fact, nowadays, the software is a bit different. Because it is actually composed from a lot of different projects. So we import some functionality from other projects and we combine it together. And all these projects, they're developed by other people. And well, these people, they have own strategies. They could go into different directions. And therefore, if a software developer tries to control such project, basically he tries to stand on the top of the pyramid and try to control the development of this pyramid. So what might happen that at some point of time this pyramid will actually like break in parts and the project will basically die. We don't want to have this situation. Here are some actual numbers that to confirm my metaphor. So basically the fraction of homegrown code in today's projects, like if you just measure the number of lines of code, is basically, it's as low, it might be as low as 5% for an industry software. And if we take the industry average, so the dependency code is 4 times bigger than the own code of software projects. Now that's the current situation. Okay, but actually, the dependencies can be also cool, right? I mean, they allow us to not reinvent the wheel. We can reuse the functionality. We can focus on specific functionality to develop our own project and to actually bring to develop the new value, right? We can develop faster and we can reuse the code of other people. But on the negative side, for the cons, so if we include the dependencies, then we will also need to maintain them. So we need to check whether the other people, whether these dependencies also have some bugs or vulnerabilities, and we'll need to fix these bugs. We will need to update these dependencies some way. So that will be the maintenance cost. And the other problem actually comes from the security. So if this imported code introduces vulnerabilities, these vulnerabilities become the problem of our project, and we'll need to also deal with them. So to control this situation, we propose to have the technical leverage metric. And for this, we propose to learn from the finance. And in finance, we have the leverage when we actually borrow some money from someone, and then we can try to use this money to increase our incomes, right? So we can create we can create a new company, or we can run another business, or we can create something new. So the same situation can be done in software. We borrow the functionality from other projects, and then we use this functionality to create something new. So we use this idea and we apply it in the context of software. So like how we leverage, how we measure the leverage in finance, we have this ratio between debt and equity. And in software, the debt is basically the size of the code that we borrow from the third-party dependencies, and our equity is at our own code that we write. So this is the metric. So you see, it's quite straightforward to understand. And we have actually a lot of similarities between financial and technical leverages. So first, we have that the financial leverage is used to undertake some investment or project with the help of borrowed money, debt. Software developers reuse already existing functionality from dependencies to focus only on the new features in their projects. Next, financial leverage decreases the corporate income tax liability and increases its after-tax operating earning. If we are talking about software, using dependencies reduce the time and therefore cost to develop new projects and sometimes increase project performance. If, for example, we can think about NumPy or Pandas if we're talking about the Python projects. In finance, the debt implies an interest rate and must be eventually paid or refinanced with some basically other money that we earn. In case of dependencies, dependencies have to be monitored and updated. And this concept is similar to refinancing one's monetary debt unless one introduces security vulnerabilities. And last but not least, financial leverage multiplies incomes, but it also multiplies losses. And this might lead to a crisis or a bankruptcy. And in case of technical leverage, the amount of work required for the dependent project to update its dependency becomes too high. The developers might, in this case, developers might decide to stop updating dependencies, and in this case, this will be basically the end of the project. Okay, so let's look at the actual data. And this plot is showing the distribution of direct leverage, and it is grouped by the size of the own code of the library. So basically, we have the number of the technical leverage, and on the x-axis, we have the size of the library itself, so the own code that was written by the developers. And we can see several trends here. So the first one, I want to start with a couple of two examples. So the first one, I wanted to show you the size of the Netty-All library. And we can see that the own side of this library, that's the network framework, right? So the size of this library is 175,000 lines of code. And well, the question would be, how many lines of code does the Java application framework should have? Well, actually, it's just 1,000. And why it's happening? Because of the technical leverage. So because the Java application framework is heavily leveraged on other software, and therefore they also capable of delivering a lot of functionality, a lot of value. And the technical leverage of the Netty-All library is just around 7. And the global trend that we can observe here, that the bigger the library, the smaller the technical leverage we have. And so this means that basically the small libraries have great leverage, and they just ship the other people's code. And that's really cool. I mean, in this case, we see that they really reuse the other people's code, and they can release better the new functionality. What does leverage? What does technical leverage can show us? And in this case, we want to assess the opportunity. So, does direct leverage really save time? For this, we built the regression model. And well, I will not go into the details of that model. I will just say you the finding, the result. We observed that for the small medium libraries that are heavily leveraged on other software, the technical leverage, the usage of dependencies is actually pays off. And what we observed that if we have technical leverage equals to 4, the delay will be just 4%. So this means that if you have 4 times more code, then you deliver this code in just with a delay of just 2 days. So that's not a lot. And well, if you have like really a lot of dependencies, like 16, the technical leverage 16, then the delay would be like around 1 week on average. So that's not a lot. Okay, so in this case, we see that dependencies are really a real opportunity for us. And what about the risk? So for risk, we check how vulnerabilities affect our libraries, our projects, and this plot shows basically the separation. So we have the technical leverage on the x-axis and the number of vulnerabilities in the library on the x-axis, and the leverage equal 4 shows us the visual separation between the cases when we have low number of vulnerabilities and the high number of vulnerabilities. And it holds for the cases, for all the cases, despite of the big libraries with own size bigger than 100,000 lines of code. And I mean, this happened because these are these very special cases. These libraries are just too big and too famous, and basically there is a lot of attention. So there is a lot of work to look for vulnerabilities in such libraries and find them and fix them. Yeah. So the conclusion here would be that, well, if you want to adopt a highly leveraged library with the leverage bigger than 4, then we need to accept the higher security risk. And how much higher? Basically, 4 times more code means 60% chance of having a vulnerability in your project. And well, here we also observe the general trend of increasing. So the number of vulnerabilities increases with the increase of technical leverage. And well, this stands for all the libraries, but not the very big ones, the most famous ones. And to basically, I'm concluding my talk here. So, but I wanted to say at the very end that to basically have the better exposure of the concept and to share it with you, we developed a website which is called techleverage.eu, and at that website you can get more familiar with the concept, and you can even have a live demo. You can play and assess the technical leverage for your own library if it works now for Java libraries. So basically, and then you can see how this library stands in the ecosystem of other open source Java Maven-based libraries. So feel free to visit the website. If you have any questions, I'm around. I will be glad to answer them. And thanks a lot for the possibility to have this presentation today in presence. Thank you.
Thanks, Ivan. You showed us some really interesting stats. Do we have some questions from the live audience? If you have questions, you can come forward at the microphone to ask it.
My question is about, usually when you use a library, very rarely you use the entire functionality that you have there, right? Sometimes it's really common you just use a very small piece of it. So how this leverage metric handles this case?
That's a very good question indeed. We might not use the whole functionality, but currently we calculate that we basically import all the functionality of the library. And in why we do this, basically the motivation is that when we import some dependency, then what happens, so under the hood, Maven basically copies that dependency and includes it into your library. So at the end of the day, you'll still have the code shipped together with your project. So it doesn't really cut the functionality from there, right? So it's still there. And we were thinking about making it more precise, that's true. And but for this particular project, we decided not to implement it yet. But there is like another direction of research that is called basically deleting this kind of functionality. Yes. So this could be really interesting direction to check, for example, which exact functionality is taken from the library, and then to visualize how big are these dependencies. That's true.
Thanks, Ilan. Now we have again a break of 3 minutes. See you soon. So now let's come to our next speaker, Andrea Janes, researcher at the University of Bolzano. He will show us an open source tool that they developed at the university, which does continuous performance testing. Janes, the stage is yours.
Thanks a lot. We heard from Eduardo before we shouldn't randomly measure stuff, but I'm proposing again a tool to measure things. I hope that you see that it's not just a random activity, but it has a purpose. So I divided the talk into 3 sections, like first, why do we need it? So to convince you that you should do it. How does it work, the tool that we propose, and how we use it at the university. So first, I talk about load testing. Testing, you might know what it is. It's to make sure that something works as you expect it to work. Load testing, you want to check that it's able to handle a specific load, like a specific number of users. Load is quite a generic term, but we usually mean 100 users, 1,000 users, 500,000 of users. You define that in your context. And then we assume that you want that this works on a specific hardware, on a specific server, with your database, using certain systems. We want to test that, so we run the test, and afterwards we look at certain metrics. The response time, so how did the software react to that? What's the throughput, so how many users could we handle? What's the CPU usage during our experiments, memory, network, disk, and so on. So we want to understand if our system is able to cope with such things. We have heard, maybe in the news you have heard of different breakdowns of servers when, I don't know, there was this bonus terme or something where everybody tried to access that website and it went down. So I assume they didn't do a proper load testing in that case. So why do we need that? Well, scalability or performance is some kind of a soft requirement. It's hard to guarantee it looking at the code. We know, if you're interested, look up the laws of Lehman from the 80s. We know that software over time degrades. As you are adding features, Lehman in the 80s said, software must be continually adapted or it becomes progressively less satisfactory. So you have to modify it constantly, refactoring it. You have to know where to refactor it and understand when it's enough. Otherwise, it will degrade over time. So what we want to do here, we want to understand if it's performant enough, fast enough, and we often want to maybe compare different solutions. We want to understand, is this server necessary, or can I go for a cheaper one? That might be a choice to make. Or we want to test if our server is capable to handle different load levels, so is able to perform auto-scaling. So how do we perform load testing? Again, we shouldn't randomly just test. In the software, we should define a goal. For example, I need to be able to handle 5,000 users. Or maybe, you know, since this year, Google is ranking the pages according to metrics that they came up with. So, for example, a first input delay means if I open a website and I click somewhere, if your response time is under 100 milliseconds, Google will rank that as good. If it's above 300 milliseconds, Google will rank that as poor, and your page will be ranked lower. So since this year, it will be important to have a certain performance also for websites. It's just an example that you should define a goal that you want to achieve, and then you can measure it. So step 3, you decide, of course, which software you want to test. You have to decide where to test that. We should, of course, not test it on your production system, so you have to come up with a realistic environment. This can be a laptop of a developer, a dedicated machine, a similar machine as your productive environment, maybe during the weekend. It can be an exact copy, but maybe it's a bad idea to have an exact copy of the production environment. Maybe it's better to have a weaker machine, because you will see the bottlenecks earlier. If you have a weak machine, you might see where different components of your software don't work quicker. And then, you run one or more tests and collect the results. And then you have to interpret the results and to understand, okay, I need to do something or I don't. And for the point 5, I want to present you this tool that we're using. How does it work? This talk is about Locust. It's an open source tool. Installation is pretty forward. It's a one-liner. What does Locust want? You have to specify the host, so an IP address to test. You have to say, please bombard this host with so many numbers of users, so 1,000, for example. Then you have to define a spawn rate. That means how quickly should this number of users go up, because you don't start immediately with 500,000 users. You will have maybe low response times just because your network is not able to send all these packets. So you typically go up with a certain spawn rate. You see here a quick one in red, still a slower one in green. You have to define how long you want to do the test. If you just test it for a minute, you will not see degradations in your system. You should run it for, 10 minutes, an hour. You can decide what is enough. And you have to specify, the last step here, the Locust file. That's kind of the nice part of Locust. It's a bit hard to read, but the Locust file defines how the software is accessed. You can define different types of users. For example, one user goes to your website, registers, and buys a product. Another user just goes to your website and looks at a product. And another user goes there and modifies the password. So you can define different interaction types. And you can tell Locust to just take, for example, randomly one of those users and simulate usage. Or you can also say, okay, take 1/4 of this type and 3/4 of another type. How do we use it? You can run it manually, just like here. You say, take this Locust file and attack or connect to that server. You will see a website like that. You can define the number of users you want to simulate, the hatch rate or spawn rate in some versions, and the host. And then you will see a little bit of statistics, and you see how the response times variate over time. This is the open source product until here. Like, you see that, and from this diagram, you have to make your conclusions, let's say. What we do, we had maybe a bit more scientific requirement. We want to conduct performance experiments, but we want, every time that we start the experiment, we want to start from a fresh machine. So we choose to use Docker. So for every experiment, we take our Locust file, a Docker Compose file, so we can undeploy and deploy the whole system for every test. And we have a configuration file where we have things like the IP address or so. This means that we have 2 machines. We have a driver, which contains our scripts, and we have the testbed. The testbed is a clean machine. It just has Docker Swarm, it has a Docker installed. The driver then deploys the system on the testbed, runs Locust, collects the results, and stores them in a database. So our tool, that's called PPTAM, you see it in the corner on the left. I want to underline, it's not that complicated. We are just wrapping Locust and making it a little bit more systematic to deploy, undeploy the machine, run the tests, and collect the results. Inside our script, somewhere you see that we are just calling Locust from a command line, passing all the parameters. So we are doing that, and then we collect the results as CSV files. The results end up in our database, so where we store the tests, the different results, all the properties that belong to a test. We store the type of metrics that we collected with it. Yeah, and having it in a database makes it easier for us to develop analytics tools, because these tools just go to a database and can visualize metrics. One thing, one result, looks a bit complicated, but I find this diagram nice because it summarizes a lot of things. We call this the polygons. So far I don't have a better name, but with this diagram we can show all the experiments done for one software and different architectures. How do you have to read it? The blue line is the ideal case. This is, let's say, the probability distribution for all the users that we expect to arrive. So we have 50 users, 100, 150, 200, and we have a kind of, this is the kind of requirement. This would be the optimal case that we want that our software supports. And then we compare here two configurations. Configuration A is the green one. And you see that A satisfies our requirement only at the beginning with 50 users. As the number of users goes up, certain parts of A start to be slower than we expect. And so we give to these parts a lower value. And so you see that for more and more users, okay, A gets slower than we want, but it kind of survives. And configuration B is at the beginning better than A. It satisfies our requirement till 150 users, and with 200 users it breaks down and it becomes much worse than the configuration A. So yeah, this diagram, there might be, let's say, clearer ones, but the nice thing is you can see in one way all the results of the experiments. Okay, so this was kind of the advertisement for two things. Have a look at Locust. There are a lot of performance testing tools that we have checked. The nice thing of Locust is there is this Locust file where you can really specify in Python how you would like that the performance test interacts with your software. So if you want to simulate clicks, you can run simulated clicks there. If you want that Locust just calls your REST API, you can do that too. If you need a little bit more, have a look at our tool pipithumb. It's on GitHub, and as I said, it's a set of scripts that help you to run experiments and also to analyze the results. Thanks a lot.
Thanks, Andrea. We still got time for some questions. Is there somebody in the audience who has a question? Can you please come forward?
Thank you. Okay, I have a question. I'm used to make this load test using all tool like JMeter, in example. That's a good tool, but of course Locust seems to have a better opportunity of control inside it. The only side effect that I see that you have to write all the steps manually. There is an opportunity of registering using a local browser the step of the user,
No.
like in JMeter.
Unfortunately not. But we also used, so first answer, no, in Locust you cannot have this record and playback. We also use JMeter with pipithumb. I mean, you can record a test with JMeter and run it with that. Just that, yeah, JMeter is a lot more powerful and more complicated.
Sure. Thank you.
Thanks.
Thank you, Andrea.
Thanks.
So we will have now a 5 minutes break. We'll see you again soon. So our next talk will be online. Our next speaker is Davide Montesini, CEO at Catch and Solve. Today he will show us his experience adopting TypeScript and how it compares to Java. Davide, welcome.
Hi, Patrick. Welcome. Welcome to all and thank you. Can I start?
Sure.
Okay, fine. So, welcome my sides to these talks. Unfortunately, I can't be present at SFSCon, but I hope you are enjoying the conference. As Patrick say, I am an expert IT software developer, and in the last time I have founded Catch and Solve startup that is located in Noi Tech Park. What we do we simulate users that navigate through websites, e-commerce apps, and we detect bugs, and we can report these problems in real time to who is breathing or managing this software. The startup is quite young, but we have made at the moment many steps. To better understand, for example, what we do, I can even show you what we have do for the SFSCon conference. We have monitored the registration to the conference to be sure that is always possible to attend to the event. We have tested the each day or more time a day the registrations in the last 2 months, and we had even one time detect a bug. This was an Eventbrite bug that fortunately was solved in less than an hour. So it means that the service has worked well for all the time. And so, what I want to talk with you today is our experience with developing our web apps. So as see before, we navigate the website, and then we record all these things we do in cloud, in a database, and we then let the user to see this data. So, for example, we have developed a dashboard in which you can see your test is working fine at the moment, is not. You can even see calendar view. So, for example, what is happening in the last month, and even the screenshot of the record, what we had do, or for the problem, as you have seen in the previous slide. So this was what we need to develop, and for us was not so easy to understand which technology to use last year to build this. What are our requirements? Also, our requirements was on a single page application that can be used using a simple browser, so a web app, so that our customer can simply log in and see all the statistics. On the other side, we need even high quality for this web app, because we are we take in account quality, so we provide a service that will monitor software. So is really important that our software that monitor other software works fine, so the customer can trust our service. Code will be maintained for years. So this was another requirement, because we have not thinking to create a prototype last year, but we want to create something that will be maintained for sure for years. And so this was another requirement. Another thing is how, also I have a very long-term experience with Java development. So it was maybe possible to reuse this Java experience or not. So the first research we made was about client frameworks that typically are used for developing single page application. We have found, for example, this chart that represent how was the satisfaction or awareness in client framework. What's for client development, what does not convince us was dynamic typing. Also we think that dynamic typing is fun, also is funny, or short. You can write some simple code quite easy, but is not ideal for complex or long-term projects because you don't have help from or less help from tools to detect if you are using the right type and so on. Another things that not convince us about client frameworks in general was they have mainly short-term life, so about a year, for example, and then sometimes say that they will introduce breaking changes. This means you maybe should rewrite some part of your code to adapt to the new version. So, and for these reasons, we are not so happy, let's say, with client frameworks. So we have even evaluate others possibility, for example, for reusing my Java experience. There are some, I will say, some frameworks, Java frameworks that can be used to create web application. I have listed here the most important we have tested. So Vaadin, that is a Java framework that use server-side code to generate your web application. So you write the code with Java, but then it will run in the browser. The technology is of type server-side. It means the code run on the server. JWT is another framework. Is quite old, I would say. It's compile Java to optimize JavaScript. JWT, the problems of JWT is that the frequency in the last time of release was reduced. It was introduced many years ago, and so at the moment is not the most interesting one. There are even other possibilities. For example, Doppio is a JVM that is written in JavaScript, so you can run your Java code directly in browser. Another things, we have even write some self-made code. So we have tried to understand how, for example, Java bytecode can be executed with JavaScript to make it work. When not Java, we have think what about to use maybe TypeScript, that is the JavaScript, but at least with some types. So this was another things we have think. It was as hard decisions, so we have take months to understand what can be the best things to do, because not all the solutions are optimal. So it's required, in any case, a little to find a compromise. But at the end, we have take the decision for developing the web application to use TypeScript and not to use or not, let's say, to base our web apps on some framework. We use library, so no, we want not rewrite all the code for the charts and so on. We use library, but the main part of the architecture of the web apps is based on JavaScript and TypeScript, excuse me. and using then library to for sure productivity or not reinvent some parts. So we have a little compare TypeScript with Java, and then is nice because it's come some nice things with this. There was some things that were not so ideal, and so we have tried to find some workarounds. For example, I think this is even quite if you use in TypeScript the var keyword, you can even use the variable before the declaration. So this is possible, but this can be dangerous because usually you can use this by mistake. So you don't want maybe use this, but for example, if you have loops, you have reused the same variable, for example, and if there are nested loops, maybe it can be a bit will create a bug. And so var was not so ideal. So what we define is to use the let keyword. With the let keyword for declaring a variable, is not possible to use the variable before the declaration or in other loops. What I will even say interesting is that even Java 10 will introduce the var keyword, so you can even use with Java if you like to not type the type of the variable, it will be inferred. In any case, with Java, you cannot use the variable before the declaration. Another difference we have found during this comparison is that JavaScript variable can contain null, like Java, but even undefined. So you should take in account that your variable can contain the value null or undefined in JavaScript. And this is important because you can maybe compare with null, but the variable is undefined. Or you must use more general comparison way like double, equals, or not to prevent this. But what was interesting is that you can use compiler parameter strict that let you more precisely define the value a variable can have. So for example, with TypeScript strict, you can define at the declaration which type you can use, even null or undefined. So you can say variable A is string or null, or only string. It means it cannot contain null or undefined. What I want to even say on the other side, Java provide the non-null annotation to, if you want, even in Java, prevent that a variable has a null value. So for example, you decide that you want that the variable always contain a string and not null. Okay, just a moment, I could finish. It was even nice because even with the strict parameter, in some cases, like for example, array index access was not respected by the compiler, the convention. So you can even have undefined if you have not say that can be undefined the variable, and so another parameter for the compiler was required. The last one problem was with the cast, because in JavaScript, in TypeScript, cast are simply removed from the code. So at runtime, there is no check for cast. It means that we have ban TypeScript cast, and we have replaces cast with function that will check at compile time and on runtime time that the type was correct. So the winner is, let's say, we can say they are as our feeling. We can use Java and TypeScript quite of the same level, using but using or pay attention at using TypeScript with some constraint, as I say before. Thank you for your attention.
Thanks, Davide, for your presentation. Now we have a break till 11. See you back soon. Welcome back. Our next talk will be about performance assessment of microservices. It will be showcased by Matteo Camilli, a research fellow at the University of Bolzano. Matteo, the stage is yours.
Thanks for the introduction. So good morning. The house is not very full, but yeah, at least the ones that are here probably are interested in. So let's get started and see how far we go. Okay, so good morning. This is, I'm Matteo Camilli, and I'm assistant professor at the Free University of Bolzano. And I'm going to talk about performance assessment of microservices with strong guarantees. So I try to motivate at least why we need such strong guarantees, why it is important, and I try to explain how we use the formal methods in this context, in this domain to perform, to carry out performance assessment. All right, so this is the outline. So we have an introduction on, I'll briefly recall what are microservices, the DevOps setting, and the importance of quality assurance, and then I'll try to explain a bit, at least from a conceptual point of view. I'm not going into the math, of course. The conceptual, aspects of our approach: automated test-based learning of performance model, and then automated verification of performance requirements. All right, and then I'll try to conclude with a takeaway message. All right, this is, microservices. I think you're all aware. This is, let's say, it's a sensitive matter. Many companies decide to deliver their business by using this paradigm. It's more or less here in between service-oriented architecture and the design principles of Unix, which essentially says do one thing and do it well. So following this kind of vision, we have a lot of independent pieces, small pieces of functionality that interact each other. Microservices paradigm lead to distribution, to cohesive, independent processes interacting via lightweight mechanisms such as HTTP, RESTful APIs, and so forth. Okay, so we all know these things lead to many benefits like modularity, increased maintainability, easier deployment, and so on and so forth. Okay. So microservices are usually developed and deployed in this setting. So by using the DevOps setting, so we have continuous interaction between developers and operators. We essentially have a lot of frequent releases in short cycles, and it's very easy to introduce changes, right? Changes at the level of the individual microservices or the configuration of the system. But it's difficult to understand the effect of these changes. it's hard to understand how these changes affect the important quality attributes of the system that eventually runs in production. All right, so this is a fundamental stage, the quality assessment, the quality assurance stage. So for each change that we introduce here, we should perform testing activities. So for instance, performance testing, if performance is an important quality attribute. Performance testing should be guided by the operational setting that is likely to occur in production. And the outcome of the testing should be used to by engineers to take important decisions, right, at the decision gates. So at the decision gate, we usually, take important decisions such as go, no go in production, or we choose the specific deployment configuration that are likely to increase performance, scalability, and so on and so forth. All these decisions are important, and they usually determine success or failure. Right, so we would like, as engineers, we'd like to make them with strong guarantees. Okay. So, but there are many questions that might arise. So, for instance, how should I drive the testing process? How do I specify requirements here? How to make the right decisions, and so on. Okay. So I try to explain how we did it. Our approach is an ongoing research activity. We have been working over the last 2 years, more or less. So first of all, to drive the testing process, we should understand, first of all, the operational setting that is likely to happen in production. So the first thing we need is to understand the behavior of the users. So here, for instance, we have, we conducted a number of experiments with this demo application, Sockshop. So here is the RESTful API. By taking the log sessions, we extract the requests over time, and out of these we can use standard, state-of-the-art techniques to extract a graph that represent the behavior of the users. So for instance, by using process mining, we can extract a graph with probability values attached to arcs, and this is essentially a DTMC model. It's a discrete time marker chain. And then what we need is to understand the workload intensity that is likely to occur in production, so we can simply monitor the number of concurrent users in production, and we can extract the empirical distribution from these data we can carry out data binning techniques and extract the important workload beans that we need then to use to test the target application. So this is the so-called discrete distribution of the workload. So we have workload, for instance, 50, 100, and blah blah. And we have frequency values associated. So for instance, this one is very important because it's associated with a very high likelihood, and this one is less important. All right, then the other important factors we need to elicitate in order to guide the testing process. The process is, first of all, the behavior, the DTMC model that I mentioned before. So we have the empirical distribution, and we might have also a number of configurations that we want to test. For instance, amount of RAM, CPU share, replicas, number of replicas per microservice, and so on and so forth. So each testing session is a pair, workload intensity and configuration, and each session shall be guided by synthetically generated users, but according to the discrete time marker chain. All right, so we developed this sort of framework. Essentially, there are a lot of details that I skip. So there is the driver node that guides the testing sessions, and the system under test node. So here we use Docker for each testing session we deploy the system under test according to the configuration C. Then we use Locust, which is an open source load testing tool to generate the synthetic users according to the workload intensity and the discrete time marker chain. And then we perform essentially during the testing process, this is where application of formal methods happened here in this overall approach. So essentially during the testing process we apply a Bayesian inference process. I'm not going into the details, but essentially we track, we record the response time for each service, and we extract out of the partial specification, which is the DTMC, we construct a CTMC, a continuous time market chain, which is essentially, I mean, again, a graph. Rather than having probability values, we have rates, okay? Why we do that? Because then we can perform automated analysis. We can use automated, very powerful tools to carry out automated analysis techniques on the continuous time market chains that we constructed during the testing process. So first of all, we can compute the cumulative probability distribution of the response time for each service, all right? And then we can compute a configuration score that combines all these, you know, that essentially we compute a weighted sum of the area under the curve of this cumulative probability distribution. So the higher this score, the better the configuration, because you know, it increases the scalability. Essentially, higher value means that here we have a higher scalability attitude. Then, yeah, we compute, this is a score associated with a particular configuration and a particular workload intensity. Then we can compute out of it, out of these values, we can combine again then and compute a total score that sums, you know, the partial score for each workload configuration. Okay, so then we have a total score. I mean, I'm not going into the details. I know it's difficult to follow, but I mean, I'll stay a bit abstract. The important thing that to understand here, that all these things that I'm explaining are automated. Okay, so you don't need to be, I mean, an expert mathematician, but there are standard state-of-the-art tools to compute these things, so they are easy to apply. All right, so then this is a visualization of the configuration, the configuration score per each individual configuration and each workload intensity. So here, I mean, this is a heat map, so we can easily see what are the configurations that are better with respect to the other. And here is the total score, so we can see what are the configurations that are likely to, you know, to perform badly, let's say, in production, and what are the best configurations. So in this case, we are a number of good configurations. So for instance, we can choose from this set the one that is associated with less resources. So for instance, if resource consumption is important, we can choose out of them the one that minimizes the resource consumption. For instance, in this case, is the configuration number 5, that is the one that uses less memory, less CPU, and it has 2 replicas per microservice. All right, then we can also, again, using state-of-the-art, off-the-shelf tools, we can automatically verify performance requirements. So since we have a continuous time market chain, we can describe performance requirements by using continuous stochastic logic. This is a formal language to describe the properties. We can define them and then automatically verify. So this is the automatically obtained, let's say, verification report out of the different testing sessions. We can see, for instance, what are the configurations that invalidate the requirements and what are the configurations instead that meet all the requirements. Right, so this is it, more or less. The takeaway message is that, I mean, I'd like to stress that take the right decisions at the decision gates, it's important, and taking them with strong guarantees is even more important. So we try to achieve this goal by integrating the usage of formal approaches in a DevOps setting. I mean, developing these kind of techniques is, I mean, it requires math skills, of course, but using these techniques is not hard. I mean, they are all automated techniques. They are implemented in very well in a very good off-the-shelf tools that can be used in a, let's say, black box fashion. So yes, I'd like to stress that everything that I explained throughout, I mean, all the techniques that I explained are automated. So everything is automated. And since this is, I mean, this is supposed to be a conference on free software, yeah, I mean, the implementation is open source. It's available on GitHub. For instance, the tool that we use to carry out the testing, the load testing session is open source. It's called PPTem, and it's available on GitHub. If you want to take a look at it, please go click, and yeah, it's free. That's it, more or less, so thanks for attention.
Thanks, Matteo. We still have some time for questions. Is there somebody in the audience who wants to ask a question? Seems like not, but thank you in any case. We'll now have a break of 20 minutes. We'll see us again later.
Woo!
Welcome back. Our next speaker is joining us from Finland. It's Petteri Kivimäki, CTO of the Nordic Institute for Interoperability Solutions. He will tell us about X-Road and open source software and about its environmental impact. Welcome. Are you ready? Petteri, can you hear me?
Yes, now I can hear you. Earlier I didn't hear anything.
Okay.
But
so,
okay.
Please start.
Yeah, okay. So thank you and good morning, everyone. My name is Petteri Kivimäki. I am the CTO of Nordic Institute for Interoperability Solutions. And today I'm going to tell you about evaluating the environmental footprint of X-Road. And let's start with a little bit of background, since everybody probably isn't familiar with NIES and X-Road. NIES is a non-profit association which mission is to develop digital government solutions to its members. And currently, Estonia, Finland, and Iceland are members of NIES. Instead, X-Road is an open source software and ecosystem solution that provides unified and secure data exchange between organizations. X-Road is used as a national data exchange solution in the NIES member countries and also in several other countries around the world. And NIES is responsible for the strategic management and development of X-Road. And NIES has set a long-term goal to make X-Road the most sustainable data exchange solution in the world. And the first step for reaching the goal is to understand what are the factors that affect the environmental footprint, how to measure them, and recognize potential improvements. To understand the current situation better, NIES performed a study together with Gofore and the Stockholm Environmental Institute. The results of the study are publicly available on the NIES website. The study was divided in 3 different phases. First, define an emissions boundary and map the main causes of X-Road's environmental impact. Second, build an X-Road carbon footprint calculator. And third, define recommendations for improving the sustainability of X-Road. The key function of X-Road is to provide secure data exchange between X-Road member organizations. X-Road is based on a 4-corner model, just like e-delivery, which means that data is exchanged through unified access points. In e-delivery, they're called access points, and in X-Road, they're called security servers. So basically, X-Road is a secure peer-to-peer network over the public internet. Since the security server is the key component which is required to process data and enable secure data exchange, it was recognized as the main source of emissions. Since the other components do not play an active role in the data exchange, they were not considered. And also the life cycle of assessment of hardware components was excluded in this study. And within the security server component, we identified 3 main sources of carbon emissions. So security server infrastructure, data transfer, and data storage. And to be able to build the carbon footprint calculator, we needed a model to calculate security servers' environmental impacts. The model was developed using existing research data, best practices, and operational data collected from Estonian and Finnish X-Road ecosystems. First, a model for a single security server was developed, and then the results were multiplied with the total number of security servers in an entire X-Road ecosystem. Another factor to consider in the energy consumption of the supporting infrastructure, for example, cooling, lighting, and so on. The factor is known as the power use effectiveness. In this project, a value of 1.58 was used, which is an average for on-premise data centers. The smaller the value, the better it is. And for comparison, some big public cloud providers have values close to 1. The final step is to convert the results into an estimation of released emissions by multiplying them by an emission factor for grid electricity. The emission factor tells how clean the grid electricity is, and it varies between different countries. Overall, the total emissions are caused by the security server infrastructure, data transfer and data storage that are affected by the power use effectiveness and emission factor. And in practice, this means that running exactly the same workload on the same infrastructure in two different countries leads to different amount of emissions. As you can see from the table in the bottom right corner, for example, if we compare the values for Iceland and Estonia, the difference is pretty significant. So even if we run the same workload using the same infrastructure, but then consider the emission factor, the difference in the outcome might be quite big. And this is the Excel-based calculator that was developed utilizing the model. Even if the operational data from Estonia and Finland was used in the development, the calculator can be used to calculate X-Road's environmental footprint anywhere in the world. So there's nothing Estonia and Finland specific about the model or about the calculator. The calculator is available for a single security server and for an entire X-Road ecosystem. First, the user must provide some input data, like number of security servers, average CPU utilization, amount of data exchanged, amount of data stored, and so on. And then the calculator shows the results as you can see on the right. There's also a comparison how many round-trip flights from Tallinn to Lisbon would be required to produce the same amount of emissions. And personally, I think that providing this kind of a very practical comparison is extremely useful, because for most of the people, including myself, just seeing these numbers, it doesn't mean much, but giving a concrete comparison makes it a lot easier to understand what the numbers actually mean. And then we use the calculator to calculate the emissions of the Estonian and Finnish X-Road ecosystems. The difference between the two countries relates mostly to the differences in average electricity grid emission factor. If you remember a couple of slides ago, we saw some examples of different factors. And well, in this case, that is the main reason for the difference. But however, the results show that around 96% of total emissions are related to the operations of security servers. And it means that data transfer and data storage, their share of the total emissions is only 4%. And here we have a list of recommendations for improvements. Even if these were created in an X-Road specific project, many of these can be applied to any software product. For example, flexibility to disable functionalities that are not needed, use of power efficient devices, use renewable electricity, and so on. They are quite good general improvements that are not related to X-Road specifically, but in general to basically to any software product. But of course, then we also have some more X-Road specific recommendations. The next step is to start implementing the recommendations that were recognized in the study. And actually, we've already implemented some of them, and they will be included in the next X-Road release later in November. But that's only the first step, and the work will continue in the future. Also, we aim to assess the environmental footprint of X-Road development processes, since this study concentrated on the software only. And it's also worth mentioning that this study concentrated only on the negative impacts to the environment. It really didn't take into account potential emissions reductions elsewhere. And what I mean by this is that X-Road, it's an enabler for digitalization, and it helps to digitalize and streamline processes and services that should have a positive impact on the environmental footprint elsewhere. So even if deploying X-Road brings new emissions, the overall aim is to decrease the environmental impact in the big picture. And hopefully in the future, we are able to conduct a study that would take this big picture into account and measure the overall impact of X-Road. Thank you for listening, and I think now we have some time for questions.
Thanks, Petteri. Do we have somebody who has a question? In the live audience, we have nobody, but maybe we have somebody on Elements. We maybe check that later on Elements itself. So thank you for your presentation.
Yeah, you're welcome, and thank you for the opportunity to join the event and give this presentation. Unfortunately, I wasn't able to come on site because of the COVID situation, but it's good that it was possible to do this online. So thank you.
Thank you. See you. Bye.
Bye-bye.
So next we will have So let's come to our next speaker, Florian Geiser. He's a young tech specialist in embedded engineering and AI. He's working in Munich. He'll tell us about how 2 open source solutions can change the next generation of mobile communication. Florian, the stage is yours.
Thank you very much for the introduction. So today I'm gonna talk about how we can use free and open source tools to improve mobile communication systems for like 5G or even 6G. So this work was part of the research project FUNKI, which stands for Funkkommunikation für künstliche Intelligenz, and I worked on it for now almost a year. So first things first, let's start with the problem before we talk about the approach. So obviously there are different things you can improve on a radio transmission, but I focused on the link adaptation. So link adaptation aims to find the optimal modulation and coding scheme for signal or for radio transmission. So in summary, this means the better the condition of a wireless channel, the more complex we can modulate signals, which means it can carry more information, and the lower code rate is necessary, which means we waste less bits for error correction, for instance. So usually each transmission standard offers its own MCS table, so modulation and coding scheme table, which contains a combination of modulation and signal coding. And we can reference to those different combinations by using an index. Traditional modulation or traditional link adaptation usually takes those tables and work more or less in a trial and error approach, but this obviously takes time, and especially in dynamic environments, this can lead to suboptimal decision making. Therefore, I was looking for an algorithm which can iteratively improve over time and adapt to dynamic environments. So how about reinforcement learning? Reinforcement learning attracted recently a lot of attention. So I'm sure most of you have already seen some funny video clips on YouTube, for instance. And the intention of reinforcement learning is to have an agent achieving certain goals in an uncertain or unseen environment. And especially when reinforcement learning is useful when there is a sequence of actions necessary. So in summary, we have 2 main parts. So first the environment, which contains the problem statement and offers an observable state to the agent, and then the agent, which observes this state and can come up with a solution or with an action recommendation. You can think of it similar as children learn or start to learn. So reinforcement learning also improves on experience over time. Enough theory, so let's come to the practical part. Basically, I used 3 different frameworks. First of all, for reinforcement learning, I used OpenAI Gym in combination with TensorFlow and Keras for handling everything deep learning related. And then GNU-Radio contained our environment, and GNU-Radio basically is a signal simulation tool. It's free and open source. And on top of that, a middle layer called GeoGym was necessary, which actually bridged an interaction between Gym and GNU-Radio. Gym is a free and open source toolkit provided by the OpenAI Foundation. So you can basically just download the pip package for Python. It is really straightforward and simple to use. and then with just a few lines of code, you already have a first demo, as you can see here. There are tons of example environments free to access on the internet, and you can just use the command gym.make to access them, and especially Atari games are very popular in the field of reinforcement learning. GNU Radio, on the other hand, is a tool for signal processing, as I already mentioned. So you can build your own software-defined radios by placing or drag and dropping either pre-built blocks, or you can build your own blocks using Python or C++ code. And then by hitting the play button, this flow graph compiles to Python code, which makes it possible for Jim to manipulate variables and also run the flow graph. On the other hand, GNU Radio needs 0MQ blocks to provide data back to the Python code or to Jim in essence, or you can either write data to files. Now that we have everything in mind, we can finally talk about the approach. So the main idea was to enable dynamic link adaptation using a simulated signal processing pipeline and relying on reinforcement learning. So the receiver basically provides a list of estimated signal-to-noise ratios to the agent, which then can come up with a MCS recommendation based on the experience stored in its neural network. The signal then gets modulated, and after this cycle finished, the receiver offers a reward to the agent based on how well the transmission was. So basically, steady and slowly, the agent is able to learn which action lead to high rewards and which to low rewards, and can adjust the neural network according to it. And here a taste of some results on an additive white Gaussian noise channel. So usually this approach worked really good most of the times, but here you have a great example why it is so important to pay a lot of attention to the reward shaping. So on the left part of the diagram, you can see the reward, which increases over time. So the reward is in essence the effective data rate in megabits per second. And on the right-hand side, you can see the action selection process, in which you can also see that the agent finally recommends MCS 5, or so action 5, which implies MCS 5. So the MCS 5 recommendation would have a theoretical data rate of 18 megabits per second, but as we can see, our effective data rate is obviously below. It's just 15.4 megabits per second. So what is the problem here? Our reward function only consists of throughput. So the agent rather loses some packets instead of going down with the modulation encoding scheme. So for instance, the next low modulation encoding scheme would be 4, which would have a theoretical data rate of 12 megabits per second. Here we have a changing additive white Gaussian noise channel. So in essence, after each step, I increase the signal to noise ratio by 1 until we hit the end of the episode. So in essence, after 50 steps, the episode is over and we turn back to a signal to noise ratio of 0 dB. And as we can see here, the action selection process looks definitely different. So instead of just recommending a single action for the whole range, it comes up with a combination of 3 different actions, again biased by the reward function. So in conclusion, let's sum it up. Basically, I used a deep reinforcement learning approach with a simulated signal processing pipeline for link adaptation. Therefore, OpenAI Gym was used as reinforcement learning environment, which is a really great tool, and you can start from really simple examples and can also build really or more sophisticated approaches, while GNU Radio as a simulation environment opens the door to the whole world of signal processing and software-defined radios. TensorFlow and Keras, on the other hand, were necessary to come up or to map the observation to an action, and which was then conditioned by the reward. So as a main takeaway from this presentation, I would like you to keep in mind that reinforcement learning isn't really difficult to apply. But there are a few details you need to pay a lot of attention, especially the reward function, as we just have seen. This is usually a big hurdle in such problem statements, especially when environments get really complex. And with this reading list, I would like to conclude my presentation. Hopefully I could give you a brief introduction to my work at Funky, and in case you weren't familiar with reinforcement learning yet, you now have another strong machine learning approach to consider for future problems to solve. Thank you very much.
Thanks, Loyan. So we still have time for some questions. Is there somebody who has a question? Seems like not, but maybe we'll see on Elements. There might be some questions later. Thank you, Florian, in any case.
Thank you.
So now we will have a 10-minute break, and we'll have our last speaker next. See you.
Ooh.
Welcome back. Last but not least, we have Charles Schulz, who's a free software and open standard advocate, and he contributed to various open source projects. He will tell us about how to secure your containers with open source virtualization. Charles, the stage is yours.
Thank you so much. Thank you so much, everyone. I'm very pleased to be speaking about containers and virtualization and security in the context of free and open source software today. So today we're going to be speaking about something which is a little bit of a hot topic in at least some corner of IT. We're going to talk about container security achieved through open source virtualization. Because in fact, this may seem like two different worlds or two different technologies, but as I really call this, you can actually have your cake and eat it too. A little bit about what it is we're doing at Vates. So I'm in charge of the strategy and partnerships at Vates. And Vates is a French open source company developing turnkey and secure infrastructure management solutions. So what we really are about is a systems company, and what we deliver and what we develop are mainly two products. One is called Xenorchestra. It's an infrastructure management solutions that does orchestration, backup, and management in general of entire infrastructure based on Xen virtual environments. That is Xenorchestra. And XCP-ng is the open source general purpose server virtualization hypervisor, and it is originally a fork of Xen, but we are now part of the Linux Foundation's Xen project. And XCP-ng, as you will see, is quite of an interesting bit of software. Now, one thing I should say from the onstart is that containers and virtual machines are not mutually exclusive. In fact, they complement each other. Virtualization, really, if you come back to the beginning of it, several years ago, obviously, virtualization was devised and developed in order to make sure that companies could take their hardware and optimize it and ensure that several applications could run on it, isolated, portabilized, but also make sure that all the hardware was being put to good use. So virtualization essentially takes care of managing systems, right? Now, the new kid on the block since at least a few years is containers and containerizations. Now, containers actually seem to sometimes be doing the same thing, but really they're not. What they do is that they handle the application management side, and they're very very useful. One of the key reasons they're useful is that they make sure they essentially portabilize the application layer. In this context, virtual machines certainly can do the same thing, but really what virtual machines can do is mostly that they virtualize and then they make entire environments portable. So if you think of it, one side is really looks at the system side of things, and the other side looks at the application side of things. Now, we at Vates have a rather long experience since 2012 of working with companies and users who are getting started, who are developing and are using hybrid cloud technologies. And usually the process of getting started with mixed environments, let's say, whether you're in a data center or an on-premise deployment or into even a multi-cloud deployment, usually goes through three very rather simply synthetic steps. The first one is setting up and reconfiguring an infrastructure or setting up a new system. And then you get the infrastructure operational and production ready. And the third one is then you take care of the application side of things. Now that's usually how it works. And what we so far were about at Vates, we were thinking that we were really about the first 2 points, setting up the infrastructure and get the infrastructure operational and production ready. But then when it comes to managing and deploying applications, what we really thought in the end was, well, this is still within the field of our core mission, which is infrastructure management. And for us, containers really are just the next piece of the infrastructure puzzle. The quote does not come from me, it comes from someone inside Vates. Now, what we really started to think about is how could we actually add value to container management and container security if we were to actually tackle this. And what we announced recently was that our hypervisor, XCP-ng, which is fully open source, is now capable of running containers in a secure fashion. And how we do this, how we achieve this is actually quite interesting. What we have been developing is an integration of a software layer called Runx. Now, Runx really comes from the world of the edge computing. It's also an open source licensed and developed layer. What it does is that it ensures that it basically is capable of running the container runtime on top of the hypervisor and on top of XCP-ng, which is a Xen-based hypervisor. And what you then do once you have that container runtime running, is that you're capable of running either Podman or Docker containers. And of course, within Podman or container, you then have your applications running. You can see here what we really have been doing with respect to the Runx integration and how this really pans out. So you basically have a tiny kernel, you have a rather minimalistic system. And how we do this and why we also use Runx is that this allows us to be both to achieve performance with respect to cloud-like use case, but what we can also do is that we can reduce our footprint. And that is especially important when you're only considering either on-premise deployments or edge computing use case. Also keep in mind something, which is that virtualized systems and virtualization in general usually tend to optimize your resources in terms of hardware, while containers tend to actually, I wouldn't say they do the opposite, but let's say if you want to run an entire Kubernetes cluster, you will soon realize that there is a difference in terms of machine and hardware usage with virtual machines running on top of a hypervisor. So we have started to do this ever since a few months, and we are contemplating the next step, of course. We have a working preview, and we encourage everyone to give it a try, test it, and we would love to have your feedback. We already have some feedback, of course. And this hopefully will soon be part of our next XCP-ng releases. The value that we're trying to achieve here is actually multi-fold. What we deliver through this integration is both security, because now you can basically have containers running in full isolation within virtual machines. What you also have is isolation, which is also extremely important because you're actually adding isolation to containers. You have portability, both achieved through containers and virtual machines. You have convenience, because XCP-ng actually turns out to be rather convenient and will be adding more convenience and user interface to the Runx API. All this, of course, is, as I said, turnkey, but it is also industry standard. XCP-ng based on Xen, Runx, it's based on the Linux Foundation Edge initiatives, and of course Podman, which is also CNCF compliant. Now, as I said, the use cases are rather broad. You now have essentially the hybrid cloud and the multi-cloud use cases where you can run containers within secure virtual environments, and you can actually make them go from, let's say, one data center to another, or go through your on-premise deployment to a data center or to a cloud platform. And that is now also very easily and very useful. Edge computing allows you essentially what we're capable of offering with regard to this is what we're basically doing effective backup and portability, as well as delivering the full confidence of managing mission critical applications. And something else which I haven't really talked about is the cybersecurity use cases, because through this integration of containers and virtual machines, you're able to deploy, manage, and backup secure virtual environments as fast as possible and with minimum friction. And if you're talking, or if you are a cybersecurity actor, you'll know that this is something which is absolutely invaluable when you are working on operations. Thank you. And if you have any questions, I'm happy to answer them.
Thank you, Charles. Do we have any questions from the audience? Please come forward.
Hi, Gianluca Boiano here, and I want to ask some details about, you previously put a lot of, weight on the fact that this solution is secure, but sorry, I don't catch the point. Where is security related to the most common technologies that not include paravirtualization, so a Doom Zero kernel as something else? And yeah, I will go with this question. I have also another question, but I will wait for sure. Thank you.
Sure, thank you. So actually, it's a very good question, and it's something that I haven't, as you said, tackled that much. Now, what we have embarked with XCP-ng, and I want you here to understand that what I'm going to talk about firsthand is XCP-ng. We have secured through essentially a government-backed initiative here in France some rather important funding to secure and essentially, secure XCP-ng. And what we have started working on since about 2 years is securing the boot chain, so the chain of boot. So from the moment you actually have the BIOS on to the moment you have the DOM Zero start. So you get the secure boot chain with signatures, etc., and so forth and so on. And what we're also working on is a virtual machine introspection. So virtual machine introspection which is something that we have started working on as well, and that we are also reusing some research work, allows you to ensure that if you need to have full isolation between specific virtual machines, you can achieve it, but you can also have specific communication channels between the virtual machines you want, and those communication channels only convey the data that you want them to convey. So you basically, that is the first layer. And so what I'm trying to get at here is we are achieving security and container security first and foremost because the hypervisor itself is secure. And then when it comes to containers, what we're saying here is that what we've been developing is a way to run those containers with minimum performance imprint or footprint, as well as with maximum isolation possible. Of course, this is a work in progress. Did that answer your question?
Yeah, of course, it's clear. The other question is about the fact that, if I can just follow, the other question is about the advantages that we already know about the adoption of container technologies. The fact that we don't use an hypervisor, somebody call it a lightweight virtualization, just to. So, what is the overhead in a flow like this where you put Doom Zero kernel? Thank you.
I think this is one of the core values, if you will, of what we're trying to achieve here. The truth is, unless what you're doing is running a simple system, and by running a simple system, what I really mean is running a simple system in terms of having containers run on your desktop or on the server, and have this run in a very simple environment. you're going to find out that container management itself can be quite complex, and there's an entire ecosystem running there. But what we're trying to do here is what we're adding systems portability and virtualization unique benefits to the fact that you can run containers. And what we do is that since XCP-ng is actually a rather turnkey tool, like you can use it, it's very easy to use, deploy, and install. What then the hope is that you're going to be able to access your container management level and your containers themselves in a very easy way, and therefore reduce, so to speak, the complexity that one can have in running those complex systems.
So, does it answer your question? Yeah, okay. Thank you, Charles, for your presentation.
Thank you. Thank you, everyone.
We hope to see you next year again.
With pleasure, and in person.
See you.
See you.
So this was the last presentation for today. There's still some tracks where we have presentations. For this track, it's over. We'll see you next year.